So, welcome to question 2 of April 2025. Yeah, of electronics. Question 2, April 2025, Teveta exam. Great. Okay, what does the question say?
The question says, question 2A, define the term commutation.
So, definition of term commutation. Okay. So, what is to commute? Okay. So, commutation is simply change of the path. If you want to imagine it, imagine a vehicle moving in a road that has got multiple lanes. So when the vehicle is changing from one lane to the next, that change of a lane. So when current is moving in a particular path, and now there's a change of the path, that is what is known as the commutation.
Commutation.
Yeah, so to write it, let's write it like this. We are going to write it like this. Okay. Let me position my camera properly. Okay. So, okay. Commutation is a switching of current I say commutation means the process of transferring. Okay. The process of transferring current from commutation means the process of transferring current from one to another.
Right.
But so that is the definition of commutation. Furthermore, I can also state that in power electronics, okay, it is the
Yes, sir.
turning off of one semiconductor device and turning on another so that the load current is transferred. Maybe we can put that one as well. But for this,
Okay.
the first part was enough for you to get the full marks. But we can say further that in power electronics, okay, it's the turning off of one semiconductor device. The turning on is in. So that load current is transferred. So that is commutation. What exactly are we talking about? Okay. So what it is that we have got current. Okay. For current to move, it needs a path. Okay. That's the only way current to what move. There must be a path. Now, when there is a change of path, then that process we call it what? Commutation. Okay. And this path in electronics is the what? A semiconductor device. Okay.
Okay.
Yes, sir.
Okay. B. Give a question. You see? See. So see. We, Mr. Joshua, welcome.
Thank you, sir. Yeah, the network has been a challenge.
So, but this says differentiate between natural commutation and forced commutation. So this commutation can happen naturally or can be what? Forced.
Forced.
Okay? Yeah. So this commutation can be natural or forced. So how does it happen naturally? And how does it happen when it's just being forced? You and me know that an AC wave is like this, right? So when there's change of wave here, from the positive side to the negative side, okay? When you use the F wave bridge, what happens? This curve comes up like this, right? So it means at this point, there's a change of direction. So instead of current go this side, you change it to make it pass through another method. It happens naturally. So the natural commutation follows the waveform. That's how the natural commutation happens. Okay? It happens by simply following the wave of the by simply following the wave of the supply voltage. That is what happens. Okay? Meanwhile, the first one, this one is by an external switch. So the one that just follows the wave is natural, where we use an external switch to change the cycle. That one it is called what? First. So natural commutation, waveform. Okay. What commutation? External switch. But in the answer that I'm going to send you, I have put a table. There are three other things that you'll be able to read from the table. But the concept is that natural commutation is waveform. Forced commutation is external switch. Is that okay?
Yes.
We proceed.
Understood, sir.
Good. Question C? She said,
Say,
yes, I can hear you.
explain the commutation angle or explain the commutation angle or overlap angle.
Angle or over angle. Okay. Commutation angle. Sometimes it is referred as an overlap angle. What is it? Okay. What is a commutation angle or an overlap angle? Okay. Good. What is the overlap? What is overlap? Just the English word overlap. Let's discuss. What does the word overlap mean? What Joshua? Mnatamba sana bora.
To overlap
When at this one is an overlapping fullback, what does it mean? An overlapping fullback, what does it mean? It means that this player,
It means
even if he's a defender, but he can also work as a striker. Not
score.
so. Yes.
like yes.
Like those days when I used to watch football, I was a Chelsea fan. We had this defender by the name of John Terry. He was a defender, but he would also score. Okay.
Yeah,
So-
score with head.
So we have said commutation is the change of what? Of lane. Okay? When the path is what? Changing. Are we together? So what is the overlap angle? The overlap angle, it is where during at that point when the commutation is happening, we are changing the path from one path to the other. But at some point, both paths are going to conduct it simultaneously. It means there's an overlap. So that is the commutation angle or commutation angle or overlap angle. Okay. So commutation is change of path. But when the path is changing, two paths conduct simultaneously. For how long do those paths conduct? It is what is known as the commutation angle. Okay. Now, let me put it down so that we can get it. Yeah. So, right during commutation, in AC system, for a short time, devices conduct simultaneously. Angle, also called the overlap angle. The phase angle, also called the overlap angle, is the difference in degrees. Is the difference in degrees representing the during commutation in AC system for a time, two devices conduct simultaneously. The phase angle, also called overlap angle, is the difference in degrees representing the overlap. Yeah. Great. We proceed. Next part of the question.
Yeah, double problem. Almost to the like we do them class up. Oh, okay.
Next part of the question.
Part D. Part D says state the different methods of firing circuits for line commutated converters.
Take the different methods. Yeah. So just stating. So number one, you see, synchronize the firing. Synchronize the firing.
Synchronized.
Using zero cross detection.
Yes, firing.
Phase control using a phase shifter. Three pulse transformer isolation. How many minutes were there for this part? Huh?
Phase.
And have digital control. 4 of them. I don't know how many they wanted, but I'm sure 4 is more than enough. So synchronized firing, phase control, pulse transformer, and digital control. Yeah. Okay. Okay.
Control.
Is it part D or part E?
Yes, control.
It's part E.
Is a calculation? Given the data given, VS 28 volts, volts. The Hz, meaning our period is what? When we are given F, we get the period 1 over F. What is 1 over 50? Partition. Oh, F is 250. So what is 1 over 250?
That's 0.004.
4 milliseconds, right?
Yes.
Correct? Great. Then we are given 2 cases. Case 1, we have been told T only is 3 milliseconds. And in case 2, T only is 7 milliseconds. Okay? So that is what we have been given. That is our data. So from that data now, what is the question? What are we asked to find?
We are asked to find average and RMS load current and load power values.
Load current and the load power values. Okay. So,
And of course, on two conditions.
Questions? Or where the other one is the 3 milliseconds and the other one is 7 milliseconds, right?
Yes, sir.
Okay, great. So, the first thing we need to do, so we are going to, first we're going to do is the case one. Okay? Where T is 3 milliseconds. Are we together? Okay.
Yes.
Good. So the first thing we need to find is D, the duty cycle. And duty cycle will always be T on over E. The T we got from the frequency, you remember?
Yes.
T on over frequency. So our first T, in our first case, our T will be 3/4. But remember, these should be in the same unit.
Yes.
That is why the moment we found is 0.004, we converted to milliseconds because this was given in milliseconds. Are we together?
Yes, sir.
Yes. Sir.
Great. So when you calculate this, this gives us what? 0.759. That is our
Yes, sir.
duty cycle. Very, very important. So, first, let us get the average load voltage. Average load voltage. V average, which is always equal to D multiplied by Vs. Okay. That's the importance of finding our D. So this will be 0.75 multiplied by our Vs. Our Vs was what? 28. What was our Vs? Our Vs was given?
Yes. 28 volts.
Great. So patch. What do you get?
21 volts.
Excellent. So now that we know our average load voltage, we can get our average load current. Average load current. I.e. average. Current is equal to what? So voltage over resistance, right? From Ohm's law.
Yes, sir.
Current is
Yes.
U R. So if we are looking for average load current, we are going to use the average voltage. So it will
Yes.
be
Yes.
V average over resistance. 21 over, what was our resistance? 24, 28.
24.
Yes.
It was 24.
Great. Punch this one. Punch.
0.875.
0.85.
0.875 V amps. That's our average load current. Okay. What else are we supposed to find?
Load power.
Load
Power.
So how do we find power?
power equals VI.
Yeah.
A squared R. Is it the
The
same?
power equal to I squared R.
Correct. Is the same with the one you said VI?
Mm-hmm.
I squared R. But I don't want you to confuse here because you will start thinking VI, which V am I going to pick? Because there are so many V's here. Okay. So even the current
Yes.
here, the current to use is the I max. Okay. Not the I average. The one we found is the I average. Okay.
Yes. Yes.
So I max is the um, is equal to 28 over 24 multiplied by the root of just wait. Okay, just wait. Okay, great. Multiplied by the root of 0.75. Or let me say the root of D, where our D was what? 0.75. Okay. So this 20, we know where it has come from, and we also know where the 21st comes from. Both of these values we have them. That is Vs over V average. Okay. So 28 over 24 times root of 0.75. That's what we get.
1.01.
We are running out of time. Mhm. What are we getting?
1.01.
1.02?
01.
1.02?
No, 01.
Not 1.02 when you round off.
No, 1.010.
Okay, good.
1.010.
Great. So that's your current. So your power of 1.01 squared multiplied by R. What was our R? Our resistance was what?
24.
Excellent. What do you get?
We're not seeing some.
Are you seeing now?
Yes.
Okay.
24.5.
So
24.5.
great. 24.5 V watts.
What?
Great. I've done for case 1. I want you to do the same and do for case 2.
Okay.
When we meet tomorrow, before we go to control, I will come and review your answers for case 2. Okay.
Okay.
Yes, sir.
Case 2, case 1, it was 3 milliseconds. Case 2 is what? 7.
7
Yeah,
milliseconds.
great. Thank you. Good night.
Thank you, sir.
Okay.
Sir.
See you tomorrow. I'm traveling to Chirundu, but hopefully I'll be back before 18. Okay? Great.
All
Thank
right,
you.
all right. Sir.